Okay, this short video is just going to finish up our conversation today. So we calculated percent yield to be 75%. This is how you can write this equilibrium system. Okay, that's what we call these when there's a forward and a reverse reaction. It's more accurate to call it a system than just a reaction, because really it's two reactions occurring at the same rate. So we can write it like this: H2 plus I2 gives us 2HI. Double arrows, okay, they don't look so great, but I think you know what they should look like. And then you write the percent yield above. Okay, we can use percent yield to categorize equilibrium systems. Okay, and I'm going to give you a little table of the four types. So if the percent yield is very close to 100%, that's called a quantitative reaction, and that's been pretty much every reaction you've studied in chemistry so far in your career. That's when you get a single arrow. Okay, so like if you're combusting hydrocarbons, you can't go backwards. They don't spontaneously form back into the reactants. That's quantitative. Using an arrow is correct. Okay, but in the example we just saw, the yield was above 50%. Obviously, it's implied it's less than 100. We call that a products favored reaction because most of the reactants became products. I hope that makes sense. If the yield is less than 50%, you call that reactants favored because more of the reactants remain. And so that's an example. If you have 40% yield, clearly that's a reactants favored reaction. If nothing's happening, less than 0.01%, we say, there's no real threshold though, and I'm not going to try to fool you with that. You just call that a non-spontaneous reaction. Nothing's going on. I didn't put in an example because why would I? There's nothing happening.